In this lesson, we're going to be talking about alternating series. We've got two objectives, as you can see. We're going to be determining whether a series converges by the alternating series test. So we're going to be able to add to our list of possible tests to see whether or not a series converges. Now, heads up, alternating series test only test for convergence. It does not test for divergence. And then the second part of this is calculating the error in an alternating series approximation. Well, when we have, say, a geometric series, we can get the exact value for that series. What is the sum of all those terms? We got a little formula for it. Most other ones we do not, and the best that we can do is approximate them with a partial sum, maybe 6 terms, maybe 7 terms. And we want to see how far off we could possibly be from that answer. That's what that second objective is all about. All right, on this assignment, you have some book work. Don't forget about the supplement. Supplement has some AP questions that you should absolutely practice. So let's take a look at this warm-up question. Find the first 5 terms of infinite sum from n equals 1 to infinity of -1 to the n plus 1 times 1 over n. So this little guy that's right here, this -1 to the n plus 1, we've seen these in other problems before. This is what's going to be like our alternator. It's going to switch the signs on our each one of our terms, because when I stick in 1, 1 plus 1 is 2, -1 to the second power is just 1, and it's a positive 1. When I stick in 2, though, 2 plus 1 gives me a 3, -1 to the third power, it's going to be negative, and our terms are going to alternate. And look at this guy over here, 1 over n. That seems familiar, 1 over n. Let's take a look at what this series looks like. So our first term should just be 1. I stick 1 in for n on that alternator, and it's positive. 1 over 1 is 1. All right, that's good. Minus a half. Why is it minus a half? Okay, so if I stick in a 2 there, that's obvious. But if I stick in a 2 up here on top, I get 2 plus 1 equals 3. Again, that's a negative number, -1 to the -1 to the third power. It's -1. All right, so the next one should be positive 1/3, and then minus 1/4, and then positive 1/5, and then so on. This is what's called an alternating series. It's alternating because each one of the terms alternates signs between a positive and a negative, positive and a negative. Now, it can't be something like plus, plus, minus, minus, plus, plus, minus, minus. It has to be every other term is positive, then negative, then positive, then negative. Specifically, this one right here is the alternating harmonic series. Do you remember the harmonic series? What's it do? That's right, it diverges. What do you think the alternating harmonic series is going to do? Is it going to converge? Is it going to diverge? That'll be one of the things that we answer in this particular lesson on alternating series. So you've probably seen these things. Whenever you're taking a road trip or something, you look off into the distance and you see these things that look like an invasion of robots or something carrying electric currents. And those currents, of course, are usually alternating currents, AC, alternating series. There's the connection. So here's a definition of an alternating series. It just has terms that alternate in sign. And here's some examples. This is the one that we just saw. This is the alternating harmonic series, right? Here's another one. Didn't have a special name. -1 to the nth times n over n plus 1, blah, blah, blah. You can see some terms. This one starts off with a negative and then goes positive, negative, positive. It's alternating. And then here's another one. -1 to the nth power. That's a geometric series, but its terms alternate. As a matter of fact, we know this one converges. We've got a test for that one. -1, -1/2 is our radius, our common ratio. That's the word for it. It's the ratio. It's less than, the absolute value of that is less than 1, therefore that thing converges. For everything else, though, for these other two, we need another test for it. And that's going to be the alternating series test. And as we're about to see, an alternating series is going to converge as long as its terms are decreasing in magnitude towards 0. So they're going to alternate plus and minus, plus and minus, plus and minus. But if those terms are getting smaller and smaller towards 0, we're adding and subtracting less and less each time, and we're going to zero in on a particular sum. So let's take a look at what that alternating series test looks like. Okay, so first of all, a sub n is our series without the alternator, without the -1 to the nth or n plus 1 or whatever that might be. Let that term be greater than 0. And then we're going to say the alternating series, and we have either -1 to the nth times a sub n or -1 to the n plus 1th. It just depends on which term starts as being positive versus negative. All right, we're going to say that that series converges. Notice that's all it says. It doesn't say diverge. It says only if it converges, if these two properties have been satisfied. The first one is we take the limit of the nth term. Again, you ignore the alternator. The terms have to be approaching 0. So there's the first part. The second part is that they have to be decreasing towards 0. And in order to show that, I can show this in one of two ways. One of them is kind of a pre-cal way. I set up an inequality, and I just check to see if that inequality is true. This is the n plus 1th term is less than or equal to the nth term of that sequence for all values of n. Alternatively, maybe I can't establish that inequality, in which case I could, of course, assign a function to it, take its derivative, and see if that derivative is negative. Right. So this, putting those two things together, shows that our sequence, our alternating sequence, has terms that are decreasing in magnitude towards 0. And again, I want to point out that this only talks about convergence. So what we would do is, my suggestion is to start right here with this, which looks like the nth term test for divergence, right? So you test that part first. And if it's not 0, you stop, because the alternating series test is not going to work on it. So then you go back to, I'll have to throw that -1 to the n plus 1 or to the nth power back in there, and then perform the nth term test for divergence, and pretty much show that it diverges. Okay, well, here, let's look at a couple of pictures here. Here's one. And in this picture, you can see that when we have ourselves some sort of alternating series here, that if they are decreasing in magnitude towards 0, each one of our terms is getting smaller and smaller and smaller. They're oscillating, sure, but they're oscillating towards 0. And when I add those terms up, I'm adding less and less, or subtracting less and less each time. And your series is going to converge to a particular number. Here's another way to see it. I think this picture here is pretty fantastic. So what you see is right in the middle here, this is supposed to be the sum that this series is converging to. And in order to see what that series is converging to, we start with some partial sums. All right, let me switch over here so that I can actually write on the screen. Oh, perfect. Okay, so the first partial sum, s sub 1, would just be equal to the first term. Our terms here are called b's, so b sub 1, right? So I would start at 0, and there's my first partial sum. All right, fantastic. Now, if I wanted to get my second partial sum, s sub 2, that would be equal to b sub 1, and you're supposed to add b sub 2, but these are alternating, so I'm really actually going to be subtracting b sub 2, and that's essentially the same thing as the first sum, the first partial sum, minus b sub 2, and that's what we have here. Here's the first sum, and then we're going to subtract off the next term in the sequence, and then I arrive at s sub 2. Right? Let's do this maybe another time here. If I wanted the third partial sum, that's supposed to be b sub 1 minus b sub 2 plus b sub 3, which is the same thing as the second partial sum, which we're going to add in the third term. So the second partial sum right here, and then we would add in b3, and I arrive at my s sub 3. Right? And now if you just continue this process, you can see that you are bouncing back and forth, getting smaller and smaller, zeroing in on your actual sum, right? So here's the first one. Oh, yeah, but then I'm going to take a little bit away. Oh, then I'm going to add a little bit, and then I'm going to take something away, and then I'm going to add a little bit and take something away, and I'm just getting closer and closer and closer to something. And that will only happen if your terms are decreasing in magnitude to 0 by the alternating series test. All right, when we come back, let's apply this alternating series test to a couple of examples.